My talk is going to be about web application security. This is just going to be a light introduction. First, I'd like to start with a quick overview. I'd like to share the goal of my presentation, a little bit about myself, and then we'll go through a brief history of hacking and cybersecurity. Then in the next part, we'll go over security standards on the internet, and in particular, something called the OWASP Top 10 and how to defend against the items in the OWASP Top 10 list. So now on to part one. What I hope to accomplish with this presentation is to give beginning developers something of a light dusting of knowledge and awareness of the cybersecurity risks that exist on the internet today. And I'd also like to share some common ways to secure your website or application and defend against those risks. But first, let me give a disclaimer. I am not a security professional. So in matters of security, I ask that you please be responsible and do your own due diligence. Thank you. So who am I? My name is Michael Metcalf. Now I'm a software engineer, but historically I've had what I would describe as maybe like a shallow interest in technology. But I was interested in it, and that might have something to do with when I grew up. So I was born in 1988, so that means I was a 90s kid. So I grew up and I watched Power Rangers when it came out. I was around for the Sega Nintendo console wars, and my family's first personal computer had Windows 95 installed on it. I can still hear the startup sound. And the 90s were an important time for technology. We had huge advances in computer graphics. Home computing was becoming more and more normalized. And along with that came the spread of this thing called the internet. Wow, it was this exciting new unknown frontier. And technology was very much a part of the zeitgeist as I was growing up, so much so that it even bled into mainstream Hollywood, particularly internet, where it got its own movie in 1995 in a movie called The Net. Surprise. Also in 1995, Hollywood released another movie that dealt with the edgier, darker side of the internet in what is possibly the greatest hacker movie ever made, Hackers. So this brought into public awareness like the internet and the things, maybe not so good things you could do on it. And it also featured characters screaming very provocative things outside of car windows, such as hack the planet. And you might be listening to all this and you might be thinking, hold up, how did we get to this point? Like, why did Hollywood think it would be a great idea to market a movie about hackers? Like, what even is hacking? We're in the mid-90s. The internet is still kind of this unknown. So what was all leading up to this? And to explore that, let's go into a brief history of hacking and cybersecurity. We'll start in the early 1900s and just move on through from there. We'll start off with a little bit of magic. In 1903, a magician called Neville Maskelyne hacked a public wireless telegraph demonstration using pretty much only a 50-foot metal pole. And he did it to transmit insults, of course. Then moving on to war years, in 1939, Alan Turing and Company famously created a computer called the Bomb, which was designed to decrypt Nazi Enigma codes. And then in 1943, we had possibly the history's first ethical hacker in a French army officer called René Carmille, who hacked the punched card system that Nazis used to locate Jews. And then in 1949, computer pioneer John von Neumann published a paper that theorized that computer programs could replicate themselves. And this is foreshadowing future malware, worms and viruses, things like that. And in 1955, at the Massachusetts Institute of Technology, the term hack was coined. In the 1960s, you started having telephone network hacking. This was called phreaking. And the picture here, this is something called a blue box, and this is what phreaks used to hack telephone networks, and they mainly did it to get free long distance. But the biggest threats in the computer science realm were mainly people just sneaking around, reading secret documents, getting information that they weren't supposed to get into. And there were viruses and malware, but most of it was pretty academic, nothing really dangerous or serious that was affecting the public yet. But then things started to escalate in the 1980s. In 1983, a film called War Games came out. It starred Matthew Broderick, and he played a young high school hacker who unwittingly hacks into a government supercomputer that is programmed to predict and execute nuclear war. And then in the following year, in 1984, this film raised computer crimes and the possibilities of the things you could do with computers. It raised this awareness on a national level, and the US Congress passed something called the Comprehensive Crime Control Act, or the CCCA. And this recognized computer crime for the first time. And then in 1986, we have something on an international level at the Berkeley Labs and ARPANET attack. So a German hacker called Marcus Hess, he hacked an internet gateway at a place called Berkeley Laboratories in the United States. And through this gateway, he was able to gain access to 400 US military computers via something called the ARPANET, which is basically the precursor to the modern day thing that we all know, love, and sometimes hate, called the internet. He sold this information to the Russian spy agency, the KGB, and this is probably the first state-sponsored cyber attack. But he was detected and captured by an astronomer called Clifford Stahl. And there's a picture of Clifford right there. He looks very proud of his accomplishments. I hope he is. Then in 1986, the CCCA, that law that was passed in 1984, levels up. And we also get something called the Hackers Manifesto. So the Computer Crime Control Act is amended to become the Computer Fraud and Abuse Act, and hacking is officially recognized as a crime at this point. Also, a hacker who went by the handle The Mentor is arrested for cybercrime, and shortly afterwards, he publishes this short document called the Hackers Manifesto. It's a pretty interesting piece of work. I recommend reading it. Then in 1988, we have the first internet deployed worm program. And it was created by a man called Robert Morris, who was a Cornell University student. And he wanted to just gauge the size of the internet, like see how many connections were actually happening on the network. But a coding error on his part caused the worm to replicate itself uncontrollably. And within 15 hours, it infected 2,000 computers and pretty much crashed the internet. After all was said and done, damages were estimated to have cost between $100,000 to $10 million. And this was historical because Robert Morris was the first person to be convicted under the Computer Fraud Abuse Act. Then in 1989, we have the first detected ransomware. Here's a screenshot of it. This was called the AIDS Infodisk Trojan. And so now already by the 90s, we have this escalation of viruses and threats dealing with computers. And this gives rise to antivirus software, the antivirus software industry. Some of you might recognize this particular software. Antivirus was okay, like it helped a little bit, but it slowed systems down. It had issues of its own. And eventually the people writing antivirus software were having a hard time keeping up with just the sheer amount of malware that was coming out. So things are starting to heat up in the security world. And, you know, coming down the pike, you're going to have people screaming provocative things outside of the car window, imploring people to hack the planet. Things are getting serious. What are we going to do? Well, my personal idea is that if we could somehow prohibit the sales of hoodies, we could decrease the number of hackers in the world by probably 95%. But another company called Netscape, rest in power, in 1995 had a different idea, and they wanted to make things secure. So they thought, what if we could secure the traffic communication over a computer network or the internet? And so they created the Secure Socket Layer, or SSL. It is the S in HTTPS. And what it does is it encrypts the communication that's happening across the network. And if you look in a website URL in your browser, you might see HTTPS, or you might see a padlock symbol. That means that website is using a secure socket layer technology, which is a good thing. So moving on to the 2000s to the present, cybercrime is ubiquitous now. It's just a part of our everyday world. And we also have the rise of hacker groups. So some of you might be aware of a group called Anonymous. They're known for wearing these Guy Fawkes masks. And we also have cybersecurity laws and frameworks being created and put into place to guide organizations in securing their applications and their companies, which brings us to some sort of standard that's going to come on the internet. So in part two, let's explore security standards on the internet. In 2001, we see the creation of an organization called OWASP. And as a developer, this is something to know about. You should know about this organization. It stands for the Open Web Application Security Project. They're a nonprofit, and they do a lot of research and surveying of security threats on the internet. And they developed something called the OWASP Top 10, which identifies the top 10 most critical security risks facing organizations. It's a staple of security reference material, and it was first published in 2003. It's regularly updated about every 3 to 4 years. And if you look at this chart, you can see that it's due to be updated this year in 2021. So with that, let's explore these with an old-fashioned countdown. We'll have the OWASP top 10 countdown. All right. So we'll start with number 10. The number 10 threat is insufficient logging and monitoring. So what is logging and monitoring? Well, your server keeps a history of its activity through logs. It's like a record book of everything that has happened on that server. It looks something like this. And then you have something called monitoring. So it's probably unrealistic to think that one person could keep track of every little thing that's happening in their logs. So there's monitoring software that will draw attention to unusual activity. And it looks something like this. So insufficient logging and monitoring means basically people just aren't paying enough attention to the tools that they have, the logging and monitoring tools, or they're just not writing logging software that is logging everything that might need to log. So how do you defend against that? Pay attention, and you want to give yourself a paper trail with comprehensive logging and monitoring. You can actually download libraries, programs, and packages that will help you write your own logs so you can specify what you want to keep track of. Number 9 is something called known vulnerabilities. And this is basically using unsecure third-party tools, libraries, and packages in your software. So this had a huge effect in 2020 in something called the SolarWinds attack, where Russian government hackers discovered that a software tool developed by a company called SolarWinds had a vulnerability in it. And Russian hackers were able to use that vulnerability to install a backdoor into this tool. And a lot of agencies downloaded this tool, such as US Department of Treasury and Commerce, and it became a huge news story. So how do you defend against this? Well, you want to know your dependencies, what you're using in your software, and you want to keep them updated. So for example, if you're using something like NPM, the Node Package Manager, there are all sorts of commands you can use to help you do this. First, you want to make sure you have the latest version of NPM installed, and you want to see your dependencies. And you want to check those dependencies then for vulnerabilities. And if there are vulnerabilities, you want to try and fix them. There's also a package called dep check that will help you check for unused dependencies in your project. Also, you can check for outdated packages. You can see when a package was last modified. You can see who maintains the package as well. Number 8, excuse me. The number 8 threat is something called insecure deserialization. So first, let me talk about what that even means. So serialization is the process of converting some object into a data format that can be restored later. So for example, if you change a JavaScript object into a JSON format. And then deserialization is just the reverse of that, where you're converting it back into its original form. And this is where the threat can happen. When an object is being deserialized from a data format, if a hacker has gotten to it, they can have the object deserialized into something malicious. So for example, let's take this snippet of code here. Let's say this is an object that's going to be serialized and sent over to a server. And you can see here that it has a username and the user's role on the website. So currently the user is Mallory and they have user permissions. But if a hacker or attacker can get hold of it, they can change the information inside and they can give themselves, for example, admin permissions and change their name. So that's a risk that can happen with deserialization. So how do you defend against that? Well, you can choose to only deserialize signed authorized data and or use alternative data formats like JSON. So using a non-native data format like JSON, it reduces the chances of custom malicious code being executed. And if you are using a language like PHP, Python, C#.NET, or Java, you want to research specific defenses against this for your language. Each language can have its own native implementation of how it does this. So you want to be aware of that. Number 7 is something called Crosssite Scripting. And what this is where an attacker can inject malicious code through a user input on a website and then use the website itself as a propagation method. So this might look something like this, where if you look in the address bar of this screenshot, an attacker has written a script to execute. And here a window pops up that says, "I'm a hacker." Or if you have like a chat window or some kind of user input like this, an attacker could possibly pass a script in there like that. So how do you defend against this? Well, actually, most browsers already have built-in defenses for this, but you also want to make sure you're using frameworks that automatically do something called escaping XSS attacks. And you also want to know those frameworks limitations. So what does escaping look like? That basically means where the framework or browser looks at a character that's been input or typed in by a user, and it changes that character into something that can't be executed as code. So for example, if you have a quotation mark that an attacker is trying to pass in as part of a malicious script, the browser or framework will see that quotation mark and then convert it into its HTML equivalent, in this case, ##34. And it would change that into unreadable code. That code couldn't execute at that point. Number 6 is security misconfiguration. This is similar. It's pretty much exactly what Yan was mentioning in her news story that she read about. And this is where you fail to configure security properly on the software you're using in your project. So maybe you're using databases, servers, or frameworks, and maybe those things come with default packages. You know, an example of security misconfiguration might be where you fail to disable unused ports, privileges, or accounts that you're using in your pre-production build. Or if you don't remove default usernames and passwords from your application, or if you forget to remove sensitive information from your production build. And the way to defend against this is to automate your build processes with repeatable and reliable scripts. This takes out the human error in configuration, and you can define exactly how you want your security configured each and every time you bring a piece of software or package into your project. And just knowing what security settings are even available to configure is a huge boost in your defense. Number 5, we have broken access control. And this is where lax or improperly set restrictions on user permissions can give a user access to things or functionality that they shouldn't have access to. So there's a company called Gibson Sec, and they did an audit on Snapchat back in 2013, and they found that they were able to build a database of Snapchat usernames and phone numbers. They reported this to Snapchat, but they didn't take enough action. They didn't secure themselves against this. And 4 months later, they were actually taken advantage of by this exploit. And a lot of user data was compromised because of it. So be careful. It is a very real thing. To defend against this, you can authenticate users when they visit a page. You can authorize in detail what users can and can't do using roles. And you can check user permissions with each user action. Basically, keep an eagle eye on your users, what they're doing, who they are, and when they're doing it. Number 4 is something called XML External Entities. And this is an exploit that's very particular. It's particular to the XML data format. So what XML is it's an extensible markup language, which is a textual markup language and data format, much like JSON is a data format. The nice thing about it is that you can check it for structural correctness before being processed, and it does this using something called document type definitions, or DTDs. And these definitions can actually be inlined into the code of XML. And these references that are inlined can refer to network protocols, and that's where an attacker can get in and take advantage of that to execute malicious code. So how do you defend against this? If you are working with XML data formats, you want to disable inline DTD parsing. And you can also limit your web browser's process permissions. So that way, if an attacker does take advantage of this and they're able to control your server, you can limit the amount of damage that they can do. Number 3 is sensitive data exposure. And sensitive data exposure is when sensitive data gets exposed. But how this happens is usually due to unencrypted communication. And one of the best ways to defend against this is to obtain an SSL, a secure socket layer certificate, and keep it renewed. So for SSL certificates, there are varying levels of security. You can get a basic free one, but you can also purchase more secure ones. If you do purchase one, you want to make sure that you renew it as soon as it expires. That's usually where a lot of these problems happen with this particular exploit, is when organizations fail to renew their SSL certificates. So be careful of that. Next, we have broken authentication. And this is where poorly implemented authentication and session management can allow an attacker to capture or bypass the application's authentication methods. So, for example, this happened in 2012 at a South Carolina Department of Revenue, where a default password was left in the authentication layer. The attacker was able to take advantage of that And as a result, almost 400,000 credit card numbers were compromised, as well as 3.6 million social security numbers. Very serious. So to defend against this, you can implement multi-factor authentication, and also don't ship with default passwords. And there's a wide variety of authentication programs that are available that allow you to do multi-factor authentication, such as Auth0, Authy, and Google Authenticator. And the number one threat in the OWASP top 10 are injections. Many of you might be familiar with something called SQL injections. That's just one kind. There's actually many of them. But yeah, that's the same thing when we're talking about injections. So this is where you inject malicious queries into a database. It's similar to cross-site scripting, but instead of attacking a website, we're attacking a database. And if your application can take in user input, that means it can be vulnerable to a query injection attack. So this might look like where you have an ID and a password field for a user to fill out. And maybe in the password field or the ID field, an attacker can pass some kind of SQL query, and that can get queried and get sent to the database where an attacker can do some pretty bad things with it. So on that note, let's talk about traffic cameras. Speaking of user input, so a traffic camera is this device on highways, and it looks at cars going by. And if a car is going too fast, it takes a picture of the license plate. But how does that picture get logged? And how does the department know to send that driver a ticket, for example? Well, the way this works is that in all these cameras, not all of them, but most of them, there's software that will take the image of the license plate number and then parse that into text and send that to a database. Well, there are many creative people out there, and one way to get around this through a form of user input is to just strap a database query onto the front of your bumper like this. So this particular query will tell the database to drop all records of their license plate number. So it's pretty clever. I actually don't know if this worked, but kudos to the person if it did work. And well, maybe I shouldn't cheer them on for that, but I can appreciate the creativeness and the cleverness. So how do you defend against this? Well, you want to parameterize your database queries. So for example, you want something like this. If you look at the text in blue, near the end, you can see where it says email equals question mark. So what this database query is going to do is it's going to check the email, the text in the email parameter, and check that against the data in the database in the email table in the email section. It's going to check it against the entries in there and to see if there's a match. If there isn't a match, nothing happens. But what you don't want is this, where you just concatenate some variable into the string. So in this situation, there will not be any check against the database entries. It'll just blindly take the text that was in that email field and concatenate it into the string. So you want to parameterize your database queries. Don't concatenate things. Not good. So that was a lot. Thank you. Thank you for hanging in there. Which one was your favorite? I think to me, injections are very interesting, especially that whole bumper database query bit there at the end. So that means we have to bid each other farewell. I'm so sorry and so sad. And while we're sad, let me give you, before we get there, I want to summarize. I hope you learned a little bit about the history of hacking and cybersecurity and gained familiarity with what OWASP is in the OWASP top 10. And I hope you know what the best hacker movie of all time is. But yeah, let me leave you with a sad stat. Yay. So in my research for this talk, I came across something that was very interesting to me, and it's that 95% of cybersecurity breaches are a result of human error. That can be very depressing and kind of shocking. But I also came across a very happy stat, something that will hearten us and encourage us. And that stat looked something like this: 95% of cybersecurity breaches are a result of human error. So I think this is all a matter of perspective. It basically means that you have the power. If you're paying attention, if you know what's in your software, what you're actually running in your web applications, how to secure it, and the threats that are out there, you're already most of the way there to being safe and secure. And with that, I'd like to thank you. You can find me on GitHub at Michael-Metcalf. You can find me on Twitter at MikeMetTech, and you can also email me at mmetcalftech@gmail.com. Thank you very much.